My question, do you guys feel poor right now? I think I need more energy because I can't even focus study right now.
I think you are hungry, Denisa, because I feel cold too.
Actually, I feel cold too. Why don't we buy fast food to eat?
Sure, why don't we?
Let's go.
A few minutes later.
Oh my god, this food is so spicy.
Is it? Let me try it.
How is
It's
it?
really spicy.
Man, it's so spicy though. Now it's time to indulge my food. The chicken is spicy too. Oh my god, I'm now started to sweating. This food is so spicy.
This is because of thermodynamics. Thermodynamics is the branch of physics that deals with the relationships between heat and other forms of energy. In this case, the energy from the food that consumed by Vanessa and Lee, which is the nasi ayam madu, which is sweet and spicy, is converted into other types of energy. That is why Vanessa and Lee started to sweat after they eat their nasi ayam madu. Digestion of food actually heats up our bodies and warms us up in the process. So, when the cold weather strikes, sometimes we think we are hungry when we are really just cold. Food, spicy food, has become a quick fix for instant comfort and warming up our system and distracting us from the discomforting feeling of being cold and hungry.
So what happens in our body? So as we all know, we as human beings metabolize our food, meaning we convert the energy from the food into energy we can use. So the first law of thermodynamics applies to the beginning and at the ends of our metabolic process. So before that, I would like to explain a little bit about the first law of thermodynamics. So the first law of thermodynamics, also known as the law of conservation of the energy, says that energy cannot be created or destroyed, but it only can change form. So based on a video which is eating, so what happens when we eat? So eating something increases the internal energy of the body because it is adding potential energy. So energy comes in tons of different forms. So by producing work either within a system or outside of it, you create heat. Then there's internal energy, which is all the energy within a system. So when heat, work, and internal energy interact together, energy is transformed. So here, delta U is the total change in internal energy within a system, while Q is the heat exchange between the system and its surroundings. And W is the work done to or by the system. So when a system releases heat or does some kind of work, so the internal energy of the system decreases. So likewise, if heat is added into the system or work is done to a system, so the internal energy of the system will increase. So any kind of energy that is released by system is absorbed by its surrounding, and any kind of energy lost to surrounding is absorbed into a system. So in all of the examples, you aren't creating or destroying energy. It's just moving from one place to another. So when I express mathematically, so delta U system is the total energy in system is always equal to the delta U surrounding. But before that, one important thing to keep in mind that about the first law of thermodynamics is that the transformation of energy is not 100% efficient. So previously I talked about the eternal energy based on the metabolism process. So our bodies are constantly losing eternal energy. So the eternal energy goes to the heat transfer, doing work, a small amount goes to the cell repair and growth, and the rest goes to the storing fat. If you eat the exact right amount of food, then your average eternal energy remains constant, so that your delta U remains at 0. So if you overeat, then you will have more eternal energy and your delta U will be positive, and your body will store this as fat. The opposite happens if you eat too little. So if your delta U is negative for the few days, so the body will begin to use its stored energy, which is fat, to maintain body temperature and conduct the work it needs to do. So the result is the weight loss. So, but how do our bodies make it so that our food can be turned into energy? So this is through a process called cell respiration. So the food is broken down and used in a number of steps within our cells, resulting the ATP, which is the main power source of the cell. So there's another process, which is the irreversible reaction during the metabolism process. So our body are great examples in showing how many thermal. So metabolism in human is the conversion of food into energy, which is then used by the body to perform activities. It is an example of the first law of thermodynamics in action. So considering the body as the system of interest, we can use the first law of thermodynamics to enzyme, heat transfer, doing work, and eternal energy in activities ranging from the sleep to heavy exercise. So for example, one major factor in the such activity in the body temperature normally kept constant by heat transfer to the surrounding, meaning that Q is negative. So that means our body loses heat. Another factor is that the body usually does work on the outside world, means the W is positive. Thus, in this situation, the body loses eternal energy since U is equal to Q minus W. It's negative. So now consider the effects of eating. So the body metabolizes all the food we consume. So eating increases the eternal energy of the body by adding chemical potential energy. So in essence, metabolism uses an oxidation process in which the chemical potential energy of food is released. This implies that food input is in the form of work. So food energy is reported in a special unit known as calorie. So this energy is measured by burning food in a calorimeter, which is how the units are determined. So there's another process in the metabolism is the irreversibility. So the body provides us with an excellent indication that many thermodynamics processes are irreversible. So why I'm saying this is an irreversible process can go in one direction but no the reverse under a given set of conditions. So for example, although fat can be converted to do work and produce heat transfer, work done on the body and heat transfer into it cannot be converted to body fat. So otherwise we could skip lunch by sunning ourselves by walking down the stairs. So that's all about my explanation about the metabolism process regarding with the first law of thermodynamics. So thank you.
But how do our bodies make it so that our food can be turned into energy? As we refer to the diagram on my left hand side, it is through a process called cell respiration. The food is broken down, then used in a number of steps within our cell, resulting the ATP, the main power source of the cell. That is how ATP is produced through the chemical reaction in our body. The chemical reaction in our body that produce ATP energy, we can call it cellular respiration. The overall chemical equation for cellular respiration is as follows. Glucose, which is C6H12O6, plus oxygen 6O2, it will produce carbon dioxide, which is CO2, water, H2O, and ATP energy. In other words, the combustion of one molecule of glucose yields 36 molecules of ATP along with carbon dioxide and water as byproduct. Since the activation energy needed for the combustion of glucose is quite high, each step in cellular respiration is catalyzed by specific enzymes that lower the activation energies and allow the reactions to occur at a pace fast enough to maintain cell needs. Our bodies are a great example in showing how many thermodynamic processes are irreversible, meaning that they can only happen in one direction. Though body fat can be converted to work and produce heat transfer, it cannot go in the other direction. Let's have a look at the energy content and availability of the major food component table. In the table, it shows that different types of foods will produce different enthalpy. For example, let's have a look at meat. Meat has an enthalpy of 22.4 kJ per gram. For egg, 23.4 kJ per gram. Butter, 38.2 kJ per gram. Animal fats, 39.2 kJ per gram. Starch, 17.2 kJ per gram. Glucose, which is sugar, 15.5 kJ per gram. Ethanol, 29.7 kJ per gram.